So it didn't eliminate anything from here. So all of these are still possible. And those 3 staff. So here's a list of all the species on the Micrococcus, Anacoccus, Spores, Sarcina chart, and those 3 staff that remain. And all of them are listed here. You have to spell these right and do proper scientific nomenclature. At this point, they're all genera. That means they're capitalized. They're all italicized. Once you get onto the species chart, you've got full scientific names. So there's Micrococcus luteus. So Micrococcus is capitalized, luteus is not. The rules allow you to abbreviate the genus after first use. I recommend against it. You're mostly just going to be copying and pasting these names. You're not going to type them all out, all by them fresh every time. So what I recommend is you write the whole thing out, because unless you're particularly good at scientific nomenclature, it's real easy to make an error, and every error in nomenclature is 1 point off on your paper. Okay? If you eliminate the entire genus, you could just put the genus and then put SP. So it would be Shigella SP period for the Shigella species. If you're very meticulous, that works. If you make a mistake, if one of those Shigella didn't actually get eliminated, it's points off. So be very careful if you do that. Okay? So everything is listed, properly spelled. This is the part of the paper you can single space. Please do single space this. Give me a double space in between tests to make it easier for me to figure out where one list ends and another begins. So now this person is going to take a look at these organisms here. These are the ones that remain after xylose. And for those organisms listed, what's the test that gives the most strike against those? It's not the one that gave you the second most strikes overall, because it's probably against most of these things you've already eliminated. Take a look at this and see from that list which test gave you the most strikes. The easiest way to do this is to take your species chart with a highlighter and highlight everything that you're eliminating. That way you can focus your eye on what's still there and just read across with a ruler and see which of those tests gave you the most strikes. That's the easiest way to do it. And then when you do the second test, and for this person the second test was lactose. These are the ones that remain, these are the ones that eliminate, so you would highlight these guys to show that they're not there anymore on your chart, and then you would just be looking at this group, which test gave you the most, and then there was nitrate, and there was cellobios, and they finished off with oxidase. You've got to get down to just one organism, and that has to be your organism. So don't pick a test that gives you a strike against your organism, even if it was the most strikes in total. Okay, you don't want to eliminate your organism. Okay, so that's the flow chart. That's worth 30 points. The most common place on the paper for people to lose points is right here at the very beginning, because they don't put all of the groups. Count 15. 11 on one side, 4 on the other. Over and over when I was grading my fall papers. Took 3 points right off the top right here. Then it comes to the journal. The journal's chronological. You may bullet point it, or you may paragraph it, however you want to do it. This person has a nice, clean presentation. Your date has got to appear. It's got to be set off in some manner so that I can pick it out easily. And you're just going to tell me what you did. And you're going to cite where needed. This person tells me once that they used proper aseptic technique throughout the project, right here, and they cited the inclusive page numbers, okay? According to Limbo from Pierce, 2010, pages 18 through 24. They don't have to talk about flaming the loop, ever, in the paper. Because they followed that. Okay? And then they're going to get their broth, and the first thing you did when you got your broth was read the broth characteristics, and here it is. And as I grade, I'm going to pull your paper apart, I'm going to lay it in front of me, I'm going to have your descriptive chart, I'm going to have your strike chart, I'm going to have your flow chart, I'm going to have your journal, I'm going to have your test explanation chart, your citation page. It's all going to be laid all across the table. And as I grade, I'm going to be checking. Every time there's a bit of information on one that should apply on another, I'm going to go look to make sure it's there and it agrees. So after I read this broth growth characteristics, I'm going to go pull your descriptive chart and make sure it's the same. Okay. So they read that, and then they streaked the 4-quadrant plate, and these 3 lines is all you have to do for the plate, because they say they performed a 4-quadrant streak plate to isolate colonies. You have to tell me why you're doing something. Why did you do a 4-quadrant streak? To isolate colonies. This person did not tell why they did a broth read. Why do you do a broth read? As I told you to. Why did you do, what use is a broth read? Or colony characteristics? Or slant read? What's the use?
The eliminate.
Surface.
Well, that's your gram stain.
It says like where it settles in the surface or the setting.
Why is that important? Why do you need to know that? Why did you look?
This is the opposite.
No, it's not.
So that you could learn to recognize your organism in this type of medium. So, you know, you did your slant read, you knew what it was supposed to look like. So if you had inoculated a new slant and it looked different, you would be alerted that you had a problem. Or if you do a broth inoculation and your organism is usually uniform fine turbidity throughout the tube, and this time it's a scummy mess on the top, you might wonder if that's a contaminant and put a little question mark by that test. Learn your organism. That's what all these things are for. And I talked about that when we were doing them, for you to learn your organisms. You recognize it when you see it. For some people, it helped them identify, because some of your organisms had some pretty unique growth characteristics. So if you're trying to decide between one and another, you look it up, you see that one description matches what you see, then it's a little more information for identification. For most of you, it wasn't relevant. So tell me why, and then tell me what you did. So this is all about the gram stain. So she doesn't tell me a whole lot about the gram stain, because you don't need to tell me about the crystal violet. You have to tell me I performed 2 gram stains, one with 5 loops on the smear and one with 10 loops on the smear. There's the colony characteristics. There, they finally got their gram stain cell shape, arrangement, and gram reaction. There's a description and an interpretation. And got the 2 slants and describe how you determine the optimal temperature. How do you know the optimal? You can't just tell me 37 degrees is my optimal temperature without also telling me that the 37-degree incubated tube had more growth. You can't, because otherwise the optimum temperature is 37 is an interpretation without a description. There's your slant characteristics, and after this they did the gram stains and started doing tests. Since this was a gram positive, once she had a gram positive Coxie, she did her catalase test, so there's the reference. And then she tells me the purpose. All of this stuff we have moved to the test explanation sheets. Okay, so this person, we didn't have test explanations this semester. So all that whole big paragraph there is picked up in the test explanation sheets, which will be in the appendix. You'll tell me you performed a catalase test and give me the reference. That is in your test explanation sheet. Okay? So the journal part of this is going to be smaller than in past semesters, which is why I'm having a hard time giving you page numbers. Okay? The biggest thing you're going to have on your test explanation sheet is your oxygen requirement, which is your FTM, because it's not a plus minus, there's 5 different possibilities. And you're going to be talking about all those in your test explanation sheets. So not all of them will be 2 tests on 1 page like the template Terry has given you. There'll be as many pages as you need. They can be as short as needed or get longer. Yes, type in that form. So where she has the lines, you can just highlight that whole thing and start typing. It does not have to be all underlined. You're just going to type behind her colon or wherever she has there. Okay? So that's the way it's going to go through your journal. Day after day. Do not tell me day 1, day 2, day 3. That means nothing. Tell me the date. And you're going to gonna have your work cited, you're required to have 3, you may have more, but you don't need more, there's no benefit. But you do have to cite everything that you referenced in your work. So there's the Brown Lab Manual, there's the Burgess, her version of Burgess, is DeVos is the chief editor, and then there's the Lab Manual, the Bliff and Pierce. Yes. I want to make sure you have a copy of everything with you as you're typing.
That'll be alright.
Okay, remember your test explanation sheets? So everywhere there is a line here, you would just highlight it and type in the date. You can get rid of the line. You could also do insert for your word, and then it would keep the same spacing. For chemical cause, this may be plenty of room for chemical cause for some tests, and woefully inadequate for others. For the FTM, you're probably going to do almost a whole page.
So you would have to like manually change the layout of this. Oh, there we go. Oh, wow.
Right?
Magic.
The lines like oh,
Okay. Remember, the chemical cause has 2 parts. What are they?
presence of
Chemical cause of any test. 2 things you have to tell me. Well, that's part of it also, but chemical cause, what the organism did, and how you know it.
Okay.
Fermentation of glucose results in acid production. The phenyl red indicator is yellow under acidic conditions. What the organism did, how you know it. Every single one of these 2 things, you've got to do that. That was the primary place where people lost points on the that extra thing on the practical. Remember when we did this on the practical? And then there's going to be your citation. This is going to be the instructions say to put it in alphabetical order. Don't do that chronological by date of inoculation. Phenyl red broths. Tell me everything the first time you inoculate a phenyl red broth. But don't tell me everything after that. So for phenyl red broths, you're going to have an abbreviated version of this that's not going to have the it's not going to have anything here. You're going to tell me your media. So that, the first time you do phenyl red glucose, you can tell me everything. Then for the second one, you're going to, for phenyl red lactose, you're going to tell me the date. You're going to tell me the name, lactose fermentation. You're going to tell me the media name, phenyl red lactose, source of inoculum, working stock of February 7th. And then you don't have to tell me all this because you already told me all that identically just before this with phenyl red glucose. Okay? And date of interpretation, you're going to tell me the date, the test name, the reading protocol. You don't need to give me that, you can. But you have to give me appearance of media and interpretation, and what your follow-up was. Because your appearance of media is going to be maybe different from your glucose. But you don't have to tell me all this detail on the inoculation. Does that make sense? If you find yourself typing the same thing over and over and over, there's something wrong. Questions? Typically you get a lot more questions once you start really typing. Everybody should be typing. That is all I have. This is your epidemiology if you want to stay and work on it. because you could get it handed in before you leave today. Otherwise,